Alright, let's go. The 2017 MCAT, day one. So, we're starting off with a nice, easy substitution problem. D is equal to u times t plus 3 times t squared. U is 3, t is 5. We want to find the value of d, so we've got u times t, or 3 times 5, plus 3 times t squared, or 3 times 5 squared. So we've got 15, and we're adding 3 lots of 25, and so we're going to get 90. So that's pretty good. Substitute a couple values in, and get an achieved question out of the way. Okay, question B, merit problem. We're solving a quadratic that doesn't have a common coefficient in all those values. So it's the real deal. We're going to have to go first term times last term, negative 18. And I'm looking for factors of negative 18 that split negative 3. So negative 6 and 3. So 2x squared minus 6x plus 3x minus 9. That's just me splitting up that negative 3x so that I can factor this first part of this equation separately and the second part of this equation separately. So a 2x can come out on the left-hand side, leaving x minus 3, and we can take a 3 out of this side, leaving x minus 3. Cool. So we can see that this bracket here is a common factor for both of these terms, so that can be factorized out by itself, leaving 2x plus 3 as its own factor as well. So this is equal to 0 all the way through. One solution is 3 for this bracket, the other solution is negative 3 divided by 2. There's your first two solutions, or there's your two solutions there for your first quadratic of this MCAT. It's a merit problem. Alright, so question C. 6x minus y is equal to 21, and negative x plus 6y is equal to 14. So we've got a simultaneous equation here. So the standard way of solving these is just set up in the elimination form. So we're just going to write them equation 1 over equation 2 like this. And now we're just going to adjust the coefficients on the values so that they are the same. So if I make the x value, the coefficient on the x value in the second equation a 6, I'll be able to add and eliminate that x value. So I'm going to multiply the second equation by 6. So first equation, 6x minus y is 21. Second equation is now multiplied through by 6. Negative 6x plus 36y is equal to 60 and 24, so 84. And now when I add these together, my x values will go away. So, no x values, 35y, and I'm going to add 21 and 84. So the 1's going to give me 85, and adding another 20 is 105. Now, I don't ever calculate an MCAT, but these both end in 5, so I know that this is going to be 7y is equal to 21, so y is equal to 3. Now, I can take that 3 and put that back into one of these equations and calculate x. So let's put it back into the second equation. Negative x plus 6 times y, or 18, is equal to 14. So subtracting 18 off both sides, negative x is equal to negative 4, so x equals 4. And now I can calculate what x minus y is, which is going to be 1. Okay, so that's like your standard way of solving these equations. So elimination method, and then we can use those terms to calculate x minus y. There is a clever way of doing this particular problem. 6x minus y is 21. Negative x plus 6y is 14. this equation minus the second, so 6x take away negative x, that's 7x. Negative y take away 6y, so we're just doing equation 1 minus equation 2. That's negative 7y, and 21 minus 14 is 7. Divide everything up by 7. X minus y equals 1. So that is the clever version. This one here is probably the version that you are most used to. Okay, let's get on to the next one. Alright, solve 9 times 3 to the x minus 4 greater than 81, where x is a whole number. Alright, so because x is a whole number, that's actually a really key concept for these problems. But first of all, I want to get these base numbers to be the same. So I've got 3 squared times 3 to the x minus 4 is greater than 87. I can't write 87 as a base number of 3, but I can sort this side out. So I'm going to have to add the powers here. 3 to the x minus 2 is greater than 87. Okay, well, I have to be strictly greater than 87, which means I'm allowed to be equal to the next highest power of 3, that is after 87. So we've got 3, 9, 27, 81. We're going to have to multiply 81 by 3, and that's going to be 243. So we're actually allowed to be equal to, we're actually allowed to be greater than or equal to now 243, which is a power of 3. So 1, 2, 3, 4, it's the fifth power of 3. So 3x minus 2 greater than or equal to 3 to the 5, which means x minus 2 has to be greater than or equal to 5, or x is greater than or equal to 7. Cool. If we went to the lower version of this, so we did this whole thing, 3 squared times 3 to the x minus 4 greater than 87, we actually could go to strictly greater than 81, so we could go all the way down and get x minus 2 strictly greater than one number lower, so 4. So x has to be greater than 6. Either of those would be the correct solution, because if x is a whole number, x is allowed to be 7 or more, and so that's saying the same thing here. We're not allowed to be 6, we have to be more than 6. So that would be 7, 8, 9, 10, and so on. So get the base numbers to be the same where possible, and then just go either greater than or equal to the next highest power of 3, or go strictly greater than the lower power of 3. Alright. E. Jane thinks of a number k. When Jane's number is cubed, the answer is m times k. Okay. When Jane's number is cubed, we get m times k. When Jane's number is squared, it is n more than k plus 5. So when k is squared, it's n more than k plus 5. So k plus 5, but then we have n more. Okay. Give an expression for n in terms of m only. Alright, well this is the only expression with n in it, so we must be replacing k squared and k with m only terms. So from this first equation, if we divide both sides by k, then k squared equals m. Alright, so k squared equals m. And then if we square root both sides of this, k is equal to root m. Okay, so that k is just root m. And we've got plus 5 plus n. And we wanted an equation for n in terms of m. So we're just going to have to subtract the square root and subtract the 5. So m minus root m minus 5 equals n, we've now got an equation for n in terms of m. It's a neat little problem. Okay. That is the end of question 1. Let's get on to question 2 now. Alright, give the equation. So we've got h equals 9 minus 4x squared. It's a difference of 2 squares actually. But give the equation for x in terms of h. So we'll just rearrange for h. So we'll add 4x squared and minus h. So that positive 4x squared is 9 minus h. We'll divide by 4. So x squared is 9 minus h over 4. And then we'll square root. So x is equal to 9 minus h over 4, all square rooted. And now there's a couple of little things we could do. I believe they'll accept this as an answer. But we like to have plus or minus when we square root. And you could actually square root the 4. So you've got 9 minus h square rooted over 2 plus minus. So those are all the same. Okay, B, we're simplifying. So you've got a quadratic on the top, you've got a quadratic on the bottom. You probably want to factorize both of those. So the top becomes minus 4 minus 1. And the bottom, we can take a 5x out, and that would leave x minus 4. X minus 4's divided by themselves are 1. So we're left with x minus 1 over 5x. So there is our simplified version there. It's probably a merit question, so that's not much work required for a merit problem. Alright, oh no, here's our next question. Alright, 2C. An L-shaped model is given here. We've got a 2, 4x minus 2, 2x plus 3, and a 12x plus 1. And we want the perimeter. Okay, so the perimeter is adding up all the sides. So we've got one big side here. Hopefully you can see this in the video, but that side is 12x plus 1. Now that would be the same as this side and this side. So we can actually just calculate all of that yellow highlighted sides as 2 lots of 12x plus 1. Then we're just going to be adding up, and I think I've got a different colour highlighter here. Then we're just going to be adding up the 2 and the 4x minus 2 twice, because we've also got this long side, which would be the same length. So when we add these two sides, 2 plus 4x minus 2, well, that's just 4x, but we've got 2 lots of that, so 2 lots of 4x, so that's the perimeter. Now, they probably want us to expand and simplify that, so we're going to have 24x plus 2 plus 8x, so 32x plus 2, that is our perimeter. Cool. So a bit easier than trying to calculate those blank sides and adding them all up. Okay. Now the area is 92 centimeters squared. What's the value of x? So we're going to calculate this rectangle, this thin one. That is a area is going to be, that is a 2 by 12x plus 1 rectangle, and then we're adding this rectangle. It's a 4x minus 2 rectangle, sorry, 4x minus 2 width and a 2x plus 3 height, and that's the area. So 92 must be equal to 24x plus 2 by expanding, plus we've got 8x squared minus 4x plus 12x plus 8x minus 6. So 0 equals 8x squared plus 32x, because I've got this 8x and 24x, and now I've got negative 4 and I'm taking away 92, so minus 96. Dividing everything through by 8, including the 0, 0 is equal to x squared plus 4x minus 12, and now I can factorize and solve. X plus 6, x minus 2, x equals negative 6, or x equals 2. You can't have a negative length. X equals 2 centimeters. And that is your solution. Hopefully that all makes sense. It's a very nice excellence question. All right, another excellence question. It's full of them. So plenty of opportunity to get excellence, plenty of opportunity to get part of the excellence questions done and get merit, and plenty of opportunity to make a start on these excellence questions to get achieved. So Leo is laying square tiles. So this whole question's in terms of the tiles, so they could be any size. A meter, 1 by 1 meter, or half meter by half meter. So he starts making a square pattern. So he knows that all the tiles are going to be able to be put into a square pattern, so that's okay. But then he changes his layout to make the length 6 tiles longer and the width 4 tiles shorter. So if we drew this, he could make a square pattern, or he can make a rectangular pattern like this. So he needs 2 extra tiles to complete the rectangular pattern. So the square pattern plus 2 more tiles will allow him to do the rectangular pattern. So he could go x tiles in this direction, x tiles in this direction to make it a square. But adding 2 more tiles will be the same as the rectangular shape. So x squared, so square pattern, plus 2 more is going to be equal to a length of 6 tiles longer, multiplied by a width where it's 4 tiles shorter. So square pattern plus 2 is equal to the rectangular's width and length multiplied together. So x squared plus 2 equals x squared plus 2x minus 24. Subtract x squared off both sides. Subtract 2. Oh, actually we'll add 24. So 26 is equal to 2x. 13 is equal to x. So there we go. We have solved, and then we need to know how many tiles we're at the start that he started with. Well, he must have started with 13 squared, so 169 tiles is what he started with to make that square pattern. Cool. It's a cool problem. Okay, question 3. The area of a rectangle can be represented by 3x squared plus 2x minus 40. Basically just wanting us to state the width and length of this. So obviously 2 things have multiplied, a base and width have multiplied to give this. So we need to find the 2 factors that multiplied, which means factorize. So we're going to multiply first and last. So negative 120. Factors of 120 is split to give 2. So 12 and negative 10. There's my split. 3x squared minus 10x plus 12x minus 40. Probably written this around the harder way, but it'd be good for you to see that. So this first half I can only take an x out. I've taken x out, so there's no squared. And I can take 4 out. 3x minus 10 is a factor for both. And x plus 4 is a factor. So length is 3x minus 10. Width is x plus 4. But they could trade positions depending on the value of x actually. So what are the possible x values? Well, you can't have a negative area. So if this was plotted, we can't have these x values in here. I'll highlight that. So in between the roots, we can't have, because you can't have a negative area. So, what are they? Are two solutions. So it's already factorized. 3x minus 10, x plus 4. It's already factorized equals 0. So one solution is negative 4, and the other solution is 10 over 3. So that's negative 4, and that is 10 over 3. The area can't be, we can't use x values that are in between, because it gives an area below the x-axis, or a negative area. So x must be less than negative 4. Alright, so all of these values, and x must be greater than 10 over 3, and greater than all of those values there. So that's your solution, which is pretty nice, that this factorization for the first part here, that's where you're going to get your achieved merit, and then here's where you're going to get your excellence. So I just do a quick sketch of a parabola. What values do I want? Do I want values outside this range, or do I want values inside that range? Cool. All right, we don't have too many more questions to go. So solve 2 to the 3x plus 4 greater than 2 to the x squared. It's already written in base form with just single powers, so we can go straight to 3x plus 4 greater than x squared. Alright, well, the x squared is positive, so let's subtract 3x and 4. Sweet, let's factorize. And we want to be less than 0, which means we want to be in between the roots this time. So we want to be in there, okay? Which means we want to be between negative 1 when we solve this and 4. So x has to be strictly less than 4, but greater than negative 1. There we go. There's our solution. I don't know what mark that would be. I think that's a excellence, because it's a quadratic inequality, so that's definitely going to get you excellence. Okay, we've got 2 more questions. Tane and Pete, they're raising funds for, I think it was football. They need $1,000 in 5 weeks. Tane gets paid $15 an hour, and Pete gets paid $16 an hour. They work a total of 13 hours a week together. I think that must be together. Okay, so what we're going to do is we want to know the average number of hours they must work each week to have the money they need. So that's quite important actually. We're going to be figuring this out on a weekly basis. So 1 week, and T would be hours worked by Tano. In a week. And P is Pete's hours worked in a week. Easy. So together, so T plus P, they work 13 hours. And they need, well, 1,005 weeks is 200 in 1 week. So $15 for every hour that T works, and $16 for every hour that P works. Should be $200 in 1 week. Let's multiply this first one by 15 because it's simultaneous equations. 15T plus 15P is equal to, what's that going to be? 15 times 13, that's going to be 165, I believe. No, all right, 13, 15. 5 threes, 15, carry to 1. 5 and 1 is 6, and 130. Sorry, 195, not 165. Okay, so that's multiplying the first one by 15. 15t plus 16p, we'll leave this one, it's 200, but we can subtract the first equation from the second equation. No t's, 1p is 5. So Pete must work 5 hours, and Tane must then work the remaining to make 13, 8 hours. So Pete's working 5 hours a week, Tane's working 8 hours a week to get the $1,000 they need in 5 weeks' time. Cool. Last question. It's quite a interesting little algebraic proof, which is quite fun. So A and B are two consecutive odd numbers. Alright, so if you think about odd numbers, what do they go up in? 1, 3, 5, 7. They go up in 2s. So that means that B is just A plus 2 if they're consecutive odd numbers. So if C is B over A minus A over B, just give C in terms of A. So we'll just replace B with 2 more than B. 2 more than A. So C is A plus 2 over A minus A over A plus 2. And now we want the denominators to be the same, so we can multiply these together. A plus 2, and that is going to be our common denominator. So what do I have to multiply this whole thing by? A plus 2. So A plus 2 squared, and I have to multiply this one by A, so minus A squared. Expanding and simplifying the top, you're going to get A squared minus A squared, but you're going to get 4A plus 4A plus 4 over A plus 2. Okay. I think that is correct. Can we simplify this down? Let's have a look. So we could take the 4 out of the top, leaving A plus 1, and on the bottom is just A plus 2. Now it also says, explain why this is always even divided by odd. Well, A plus 1 is even. 4 is obviously even, so 4 times A plus 1 is even. An even number multiplied by anything is going to be even, isn't it? Now on the bottom, we've got an odd number, because we've got A plus 2, which is an odd number. So this is the numerator. You might want to write a bit more in the MCAT than I am. Denominator is odd, because we've got A, which is an odd number, and A plus 2, which is an odd number. So you've got an odd number of odd numbers, always odd. The multiplication of 2 odd numbers is always odd. The multiplication by an even number is always even. So that's basically what sentences you want to write at the end. I think that's a pretty nice MCAT, to be honest. Cheers.